Welcome to our first video for regular calculus, and we're going to start right off with the Unit 1, which is our review unit. And I just want to put a little emphasis on this and say that I know these are going to seem like pretty simple concepts. You've all seen these before, but the biggest challenge my students have when it comes to doing calculus is never really the calculus part. It's more the building blocks that you learned in pre-calculus or algebra 2 or algebra 1. So I'm trying to fill in those gaps right now in order to not have those problems later on. So stay with me as we go over. This first one's going to be laws of exponents, some factoring, and then quadratics, and then we'll call it. So let's just say guided notes for our name. So here are our basic laws of exponents. The first one, we know that when we multiply like bases, so we're just going to denote those as x, multiplying like bases, we add the exponents. So m plus n. Likewise, and I want you to think about this for a second, if you raise anything to the 0th power, that's equal to 1. If you take something with an exponent and you raise it to an exponent, this is where we multiply those two exponents. And the reason for that is because multiplication is, raising something to a power is just multiplication, n times. So let's say x to the m, and that would be, we're multiplying this n times. And if we follow that same logic, we're just adding each one of these. So it would be 1 plus 1 plus 1 plus 1, n times, which is why we just multiply these two. Third one, anything raised to the first power is itself. That's what we call the exponent identity. Now, if we think about some of the other operations that we deal with, if we have division, when we divide like bases, that is where we subtract the exponents. Likewise, anything with a negative exponent, we can write that as the reciprocal. So 1 over x to the m, or if we went in reverse, if we had something in the denominator, we could easily write that as something to the negative exponent. Things that you'd be surprised how many people miss here. If you have multiple things inside parentheses raised to a power, we need to distribute that. Each of those has an exponent of 1. So we're raising both of those to the power of m. You'd be surprised when we have something, let's just say 2x to the third, and let's say we want that to the 6th power. I would get people say that that's 2x to the 18th, which is incorrect. We have to distribute that. That would be 2 to the 6th, and then x to the 18th. And 2 to the 6th is 64, so we could just rewrite that as 64 x to the 18th. And then last bit, if we have a division problem raised to the m power, then we distribute that exponent. So we have x to the m over y to the m. Now, let's do a couple examples here. So this says write each of the following expressions in this form, where we have everything in the numerator. There's no division. And then we'll see a couple of these on the homework problems that I'm going to assign to you. So first things first, I'm going to distribute this cubed power. So that would give me 2 cubed a to the 6th. And then I'm going to raise this b term up into the numerator. Since it's in the denominator, we just make it negative. And then last bit, because I know you guys can do this, 2 cubed is 8, a to the 6th, b to the negative 1st. If we have something under a radical, the fancy word for a radical is a surd, S-U-R-D, surd. This means instead of using roots, we can talk about surds. Regardless, this is the same thing as writing 9ab cubed to the 1/2 power. If this was the third root, we would write 1/3. If it was the fourth root, we would write 1/4. You get the picture. Radicals, or surds, are just fractional exponents. Then, following our properties, we distribute this across all of them. So that would be 9 to the 1/2, a to the 1/2, b to the 3/2. They're all in the numerator. And then the only other thing that I ask you to do to simplify is the square root of 9, or 9 to the 1/2, is 3. a to the 1/2, b to the 3/2. Now, if you're wondering why, here's a simple aside. So, semicolon. If I have 9 raised to the 1/2 power, I can write that as 3 squared to the 1/2 power, and now I can distribute that exponent on the outside, and that would give me 3 to the 2/2, which is 3 to the 1st, which is 3. That's what you're doing when you're simplifying square roots. So, first thing from algebra, we learned exponents. Now let's talk about lines. You might remember the most common way of writing a line is y equals mx plus b. If you ever wonder why we use the letter m to write for slope, m is French for monter. I'm going to spell that wrong, but monter, which means to climb. The funny thing is, if you were in France, they use y equals sx plus b, where s stands for slope. And if you took a stats class, you'll see this as y equals ax plus b. All of these are for the same thing, where m is the slope and b is the y-intercept. Pick your poison. The one that we use most frequently in calculus is our point-slope form, because what we're going to be doing with writing the equation of lines, specifically tangent lines, is we're going to find a slope, and then we're going to use a point. So y minus y1 equals m times x minus x1, where m is your slope, and your point, let's call that p, is denoted x1 comma y1. So we have an x-coordinate and a y-coordinate. Those go in here. So we're just saying any y value, which is why we use the variable, minus the specific y point equals m times x minus the specific x value in the coordinate system. The last bit for standard form is ax plus by equals c. This is a great way of finding x and y intercepts, and since almost every polynomial equation has a standard form, this is the way we write the standard form for lines. If you forgot, the slope formula is m equals y2 minus y1 over x2 minus x1. Okay. I'm going to read the example. I'd love for you to pause this video, but I know just in terms of time's sake, I'm going to go through this problem. So determine the equation of the following lines. The line through the point 2, 3, and the midpoint of the line segment from negative 1, 4 to 3, 2. So midpoint is the middle point between two things. So what we do is we just add the x values, divide by 2, add the y values, divide by 2, which gives us a slope, the point that we're working with is 1, 3. Now we want the line through 2, 3, and 1, 3. I'm just going to show this to you. We got 1, 2, 1, 2, 3, sorry, and then 1, 3. If you drew the line between these 2 points, you see that it's a horizontal line. The equation for this would be y equals 3, because no matter what x value you are at, you are always going to have the exact same y value. The y value never changes, hence y equals 3. X can be whatever you want. Similarly, if you had a vertical line, we write those as x equals, where x remains constant and the y value can change for whatever. Now, B, find the line through these 2 points. First thing we need is the slope of those 2 points. So what we do is we take the y values, 4 minus 1 over negative 2 minus 7, which gives us 3 over negative 9. If you choose a different order, as long as you stay consistent with both the numerator and the denominator, the answer will be the exact same. If we simplify our fraction, we get negative 1/3 as our slope. Now, I'm just going to say this. Keep it simple. We found our slope. We have a point. Use point-slope form. It's the simplest way. Point slope. So I'm going to take the first one. We're going to be y minus 1 equals negative 1/3 times x minus 7. Piece of cake. You could have also written this as y minus 4 equals negative 1/3, because that's their slope, parentheses, x plus 2. Inside parentheses, we always write the opposite. Outside parentheses, we always have the same. Technically, you could have parentheses around the y value too if you wanted to. You don't have to. Here's also, just as another quick aside, if you ever wonder where point slope form comes from, I'm just going to divide both sides, this first equation down here, by x minus 7. And if we have y minus 1 over x minus 7 equals negative 1/3. That's our slope. Here's the difference in the y's, and here is the difference in the x's. I'm going to zoom in there just so you can see. I'm using this triangle symbol. If you recall from previous math classes, that means delta. Delta means change. Delta means difference. Difference is the subtraction. So if you ever wonder where point slope comes from, it's literally the slope formula just expanded out. Last example on lines. Find the point of intersection of the lines 2x minus 3y equals 0 and x plus 4y equals 11. So in order to find the point of intersection, we are going to use a system of equations. In this case, I'm going to write these two right over each other and do a little elimination. You could also do substitution if that is your jam. So we have 2x minus 3y equals 0 and x plus 4y equals 11. I'm going to multiply this second line by negative 2 so I can cancel out the x's. I'm going to rewrite this. 2x minus 3y equals 0. Negative 2x minus 8y equals negative 22. We're going to add these together to eliminate the x's. I get negative 11y equals negative 22. So y equals 1. So that gives me my y value. Mr. Swenson, stay focused. 22 divided by 11 is 2. So this is my y value, the y value of my solution. I'm going to plug that back in to either equation, doesn't matter. So if I plug into the second one, let's say, I have x plus 4 times 2, because that's the y value, equals 11. So x plus 8 equals 11. What number plus 8 is 11? X is equal to 3. And I would like you to write your answer as the ordered pair, parentheses, 3, 2. I tend to box my answers in. Sometimes I forget. Don't sue me. Okay, parallel lines. Two lines that never cross. Parallel lines have the same slope. Perpendicular lines, on the other hand, meet at a 90-degree angle. So how do you find the slope of a perpendicular line, or the normal line, or the line tangent? We do the opposite reciprocal slope. So in this case, if our slope originally is negative 2/3, then our normal slope, or our perpendicular slope with that upside down t, would be positive 3/2. Flip the guy, change the sign. Flip and change. One more simple topic, and then we'll call the video for today. Let's talk about completing the square. Completing the square is wonderful when you're working through graphing quadratics. And that's what the start of the next video will be. So here is a quick refresher. There's two ways of doing this. I'm going to show you one way. I'm going to add the 7 to the other side. And I'm going to put parentheses x squared plus 6x plus blank. Okay, we take this middle term, as long as there's not a term in front of the x squared. Take this middle term, take half, so half of 6 is 3, and square it. Half, then square. which gives us 9. Whatever you do to one side, you do to the other. So we added 9 on one, we add 9 to the other, which gives us y plus 16 equals, now we use this half term, which would be x plus 3 squared. Now, if you wanted to get fancy, you could say this is just y equals x plus 3 squared minus 16. If you have everything on one side, this also tells you that the vertex is inside parentheses, we do the opposite, so negative 3. Outside parentheses, we stay the same, would be negative 16. Now, I'm going to do this in a slightly different color, say purple. For those of you that are slightly more advanced, if you want to just keep everything on the same side from what you're given, let's say y equals x squared plus 6x. What I do is I like to give a little space, and then I have minus 7 over here. I'm going to have this little spot here. I don't have anything in front of my x squared, so I put parentheses here, plus 9, because we already did that. Well, if you're adding 9 in here to keep everything balanced, because you don't want to be changing the equation, we would subtract 9 on the outside. And then here's our perfect square trinomial. That would be x plus 3 quantity squared minus 16. So pick whatever you want to do, but you'll get the same answer regardless. Now, what happens when it's not so nice? So first off, I'm going to get the y on the other side. So we have, I'm going to keep the y on one side and move everything else to the other side. That's what's going to work out. So I'll have 2y equals negative 3x squared minus 3x. Then I'll divide everything by 2. Y equals negative 3 halves x squared minus 3 halves x. Now, in order to complete the square, we cannot have a term in front of the x squared term. So I have to factor out a negative 3 halves from both of these x terms, which leaves me with x squared plus x plus, leave some space. Likewise, because I have the y value on the other side, I'll give that a little space. So I'll have y equals that. Okay, technically the number in front of the x is 1, so I take 1 half of 1, which is 1/2, and then I square it. It gives me 1/4 on the inside, so I'm going to subtract, technically it's 1/4 in here, but I have to multiply by negative 3 halves. So negative 3 halves times 1/4 is negative 3/8. And I could have that on the left side, whatever you do to one side, we do to the other, or I can add 3/8 on the outside. I'm just going to add 3/8 to the outside. Again, that's negative 3 halves times 1/4 to keep everything balanced. So my final answer would be y equals negative 3 halves, parentheses, x plus, because that's positive, 1/2 squared plus 3/8. We're going to pause here. The next video will go about quadratics and graphing polynomials. And then I want you to work on some of these problems at the end of the unit.